Approximate the area under the curve, f of x, graphed below, from x equals 1 to x equals 4 using a left endpoint approximation with 3 subdivisions. Round your answer to 3 decimal places. Okay, so we have a graph of a function involving a square root. So 1.8 times the square root of x. We are interested in the region from x equals 1, so this starting value here, to x equals 4. And we want to find the approximate area under the curve with 3 subdivisions. So the width of my subdivision, which is delta x, we take the length of the interval, divide that by the number of subdivisions that we want. Here it's rather nice because it distributes evenly to 1. So what that means is to get the approximate area, I would calculate the height of the curve at integer values. So that gives me 3 separate, equally spaced subregions. But it does give me 4 different numbers. So when I go to get the areas of rectangles, I do need to be careful. I need to pick 3 of those 4 numbers. But which 3 matters as to if you're using left endpoint approximations or right endpoint approximations. So using left endpoint approximations, we use the left side of a rectangle to find its height. If you were using right endpoint rectangles, you would use the right side to find its height, which would give you a different approximation. But left endpoint approximations, we would use these 3 points here. So this one, and this one, but not that one. So how do we go about this? Well, we get the area of a rectangle by doing, we'll say, height times width, because we're just multiplying 2 dimensions here. You can say length times height, however you want to call it, but you're just multiplying 2 dimensions. The height of each rectangle is going to come from the function evaluated at a specific point. The width is always going to be delta x. That's why we are using delta x. So to find the area of the first rectangle, so we have the first rectangle is starting with the point 1, and the area of that rectangle is going to be f of 1, f of 1 times delta x, which is 1. So that is going to be, let's see, 1.8 times the square root of 1, and then times 1. So that's f of 1 times 1. So we get 1.8. So the area of this first rectangle right here is 1.8 units of area. Now, the next rectangle, the height of the rectangle is defined where x is 2. So we're going to compute f of 2 and then multiply that by the width. And since that's 1, it's obviously not going to change anything, so it's really just 1.8 times the square root of 2. So 2.546, let's just go a few decimal places here. And that gives the 2 numbers multiplied together gives me the area of this second rectangle. And you know what, just thinking ahead here, just being careful, I'm going to say this is just 1.8 times the square root of 2, which is approximately 2.546. Because the thing is, when you round a number off, you introduce error into your calculation. And those of you going into engineering really need to pay attention to that sort of thing, because the slightest amount of error propagated over a large amount of span it can make bridges not meet in the middle and, stuff like that. So anyway, we'll try and not round anything until the very end. The next rectangle, the height of it is going to be defined by f of 3, and its width is still just 1. So when I multiply those two together, that will give me the third rectangle, and that's obviously going to be 1.8 times the square root of 3, and that is approximated. If we just do that computation, 3.118. Okay, so now the total area of these three rectangles is just the sum of these numbers. So I could take the sum of 1.8 plus 2.546 plus 3.118. That would give me an approximate area, but just to make sure I'm getting the best approximation I can, I think what I'm going to do is write it like this. I will say it is 1.8 plus 1.8 times the square root of 2 plus 1.8 times the square root of 3. And that gives me 7.463, and 3 decimals is generally appropriate. That's the site's default accuracy. If we would have used the other numbers, it probably would have been slightly off, but very close. And there is answer tolerances within the site, so it's possible that it would accept 7.374, but it's possible that it wouldn't accept it. So that's just propagated error because of rounding. So to prevent that, you can add more decimal places, or do what I did and try and prevent rounding until the very end.